Okay, in this problem, we're going to look at this circuit. We're going to find the equivalent resistance. First, we're going to redraw it, and then we're going to find the voltage across and the current through each of the resistors. So I suggest you actually try to go through this problem yourself first, and then come back and look at the video. Okay, so the first thing we're going to do is we're going to redraw the circuit. So I'm going to do this. That's my dog pacing around if you hear a strange clicking. So this is going to be R1, 200. This is R2, and this is 200. This is R3, equals 100 ohms, and this is R4, 100 ohms, and R5 is 200 ohms. Okay, so what we're going to do first is we're going to combine, let's see, draw. We're going to combine these two resistors. We'll do that down here. R1. Let's see if I can erase that. It's my R1, and then I'm going to have my R2, and I'm going to have R3 and 4 together here. R3, 4. This is R2, R1. This is R5. Okay, and so if I combine R3 and 4 together, so I'm going to have R3 plus R4, that's going to equal R3, 4. I'm going to get 100 plus 100 is 200. So R3, 4 is equal to 200. R2 is equal to 200. So when I combine those, this is my R1, I'm combining 200 plus 200. So my 1 over R234 is equal to 1 over R2 plus 1 over R34. And so that is equal to 1 over 200 plus 1 over 200. That's equal to 2 over 200, which is equal to 1, or 2 over 200, which is equal to 1 over 100. So 1 over R234. So R234 is equal to 100. So I'm going to have this. So this is going to be R234 is equal to 100. This is equal to 200. And R5 is equal to 200. So I'm at a voltage divider. Terrific. So I can find REQ of the total. So REQ is equal to, I just add those together, R1 plus R234 plus R5. And so I get 200. 200 plus 200 plus 100 is 500. So my total, so I end up with a circuit that looks like this. This is 500. This is, what was our 20 volts. So I can determine the current for a 500 ohm resistor. So I is going to equal 20 volts, so V over R. And I'm going to have 20 volts over 500 ohms, which gives me 0.04 amps. Okay, so now I can use that current. If I look back at my voltage divider, R1 and R4 are not part of an equivalent resistance. So I know, like looking back at my circuit up at the top, here, R1 and R5, I can just multiply the current times the resistance for each one and find the voltage. And then once I have that, that'll tell me the voltage for these equivalent resistances that I have. So let's do that first. So we'll do R1 and we'll do R5, and they're going to be the same, right? Because my current is the same, my resistances are the same. So I can say that my voltage, let's undo that. So V1 is equal to V5, and that's equal to I times, let's just say R1 since they're both the same. So I'm going to have 0.04 amps times 200 ohms. And so V1 and V5 are equal to 8 volts. So just looking back at my voltage divider here, my voltage divider right here, so that means I have 8 volts dropped across here. I have 8-volt dropped across here, and there's 20 volts here. So that tells me that here I must have 4 volts. So we can start filling in our table. So I know R1, I have 8 volts here, and R5, I have 8 volts. I also know that my current through R1 and R5 is 0.04. So 0.04 amps. And I'm just going to make amps here so I know that that's what the unit is because I can't really fit it. Great. Okay, so now what about R2, R3, and R4? Well, if I look, R2 is the only resistor here. So I know the voltage drop from here. Do that in red. So erase that. The voltage drop here to here, right, is 4 volts. So I know that there's a 4-volt voltage drop across R2. So I can just write that in. So this is going to be 4 volts, right? And I can figure out the current for that in a minute. Since I know though that 4 volts, I'll know, let's just do that right now. So if I have 4 volts across R2, so I'm going to say, what is the current I2? Oops. So I2 is equal to V2 over R2. And so that's equal to 4 volts over 200? Over 200, yeah. 4 volts over 200 ohms is equal to 0.02 amps. Okay, so I can fill that in. So I've got 0.02. And now R3 and R4, well, if 4 volts are across R2, they're also across R3 and R4, and these are in series. So that means that I have to drop half of the voltage. So I have to drop 2 volts across here and 2 volts across here. So I can write 2 volts here and 2 volts here. And I know the equivalent resistance here is 200. So if I go and look right here, right here, right, the equivalent resistance, because they're in series, is 200. So I can use that 200 as my to determine my current. So really, because the equivalent resistance, they're in series, it's equal to 200, then I'm going to have the same equation. I'm going to have 4 volts, right? 4 volts. So I3 is equal to I4. They're in series, and that's 4 volts over the equivalent resistance of 3 and 4 over 200 ohms, and 0.02 is my answer. So for each of these, I have 0.02. And then I can just check to make sure that my Kirchhoff current loop rule, right, about the node. So if I come into this node with 0.04 amps, right, so I'm going this way with 0.04 amps, it splits, and because these resistances, right, if I go down here, right, I go like that and I go like that, so I'm splitting them off. And so if this is 4, then this has got to be 2 and 2, right, because these two resistances are equal. So 0.02, 0.02, and 0.04. So it makes sense. So it filled everything in. So that's how you go about filling in one of these tables.